Hello students, today we will be discussing problems as the continuation of the previous session. So in the previous session we have done some problems related to VCR system, right? So different types of VCR system today. So we will be doing this problem, a simple saturation cycle using R12. So 2 points, simple saturation cycle with the R12 as the refrigerant is taking a load of 10 ton. So the total load Q is 10 TR, ton of refrigerator and ambient temperature are minus 0 degree Celsius. Okay, so this is 0 degree Celsius and 30 degree Celsius respectively. A minimum temperature difference of 5 degrees Celsius is required in the evaporator and condenser for heat transfer. So, given evaporator temperature and condenser temperature are not directly given, but it is given that they are having a 5 degrees Celsius different difference from ambient temperature and refrigeration temperature. So, this is TR refrigeration temperature. This is TA ambient temperature. So, evaporator temperature TE will be some TR minus 5 degrees Celsius. So it should be lower than the refrigeration, the temperature of the space to be refrigerated. And TC will be 5 degrees Celsius plus ambient temperature. It should be higher than ambient temperature. Then only heat transfer will take place from condenser to ambient or atmosphere. Evaporator temperature should be lower than the refrigeration temperature. Then only heat transfer will take place from refrigeration, the space to be refrigerated to the evaporator. So this both you have got, and we have to find mass flow rate through the system, power required, COP, cylinder dimensions, using assuming L by D equal to 1.2 for a single cylinder, single acting compressor if it runs at 300 RPM. So students, here drawing the TS diagram. So this is a simple saturated cycle, right? So simple saturated cycle will be like this only. Simple saturated cycle. 1, 2, 3. So if in particular, if in question it is given specifically that there is some undercooling or the inlet, the input of compressor is superated or wet or something like that, then only you have to change the diagram. If it is given directly simple saturated, you draw like this only. So this is 1, 2, 2 dash 3, 4. So students, this temperature is nothing but TE. This temperature is nothing but TC. So TC is 5 degrees Celsius upper than 30 TA. So it will be 5 plus 30 equal to 35 or 308 Kelvin. Similarly, TE will be 0 minus 5 is equal to minus 5, right? So it will be 268 Kelvin. So this is 308. So this is 268. Okay. Now what should be found out? It is also given Q equal to 2, how much? 210, right? Sorry, 10 TR. 10 TR means 210 kilojoule per minute. Sorry, 2100 kilojoule per minute, because it should be multiplied with the 210. So this will be the. So actually we know the refracting space. This is the refracting effect or the refracting capacity. So it is actually H1 minus H4, right? So H1 minus H4 is heat transferred per kilogram, right? Per kilogram. So Q will be H1 minus H4 into m dot R. So if you multiply it with the total mass flow rate, then you will get the total capacity. So you should multiply it with the m dot R. So H1 minus H4 you have to find out. Q is directly given. So here students, 2100 equal to m dot R into H1 minus H4. So if you know the value of H1 minus H1 and H4, you can get the value of m dot R. So H1 is here. So this is enthalpy of saturated vapor at 268. And H4 is equal to H3 itself, right? H3 itself. So H3 is HF3. So enthalpy of saturated liquid at 308 Kelvin. So you can find out H1 is so you have to use the gas table, sorry, refrigerant table. So refrigerant table corresponding to R12, corresponding to H1 is 268 Kelvin, right? So minus 5 degrees Celsius. So around between minus 6 and minus 4, so that will be around 349. So you can take H1 as, you take it as 350, okay. 350.5, we'll take it as 355, and H4 will be equal to H3 is equal to HF3 itself, so it is corresponding to 35 degrees Celsius, right? So you use the second table where you can find 35 means here, so it will be HF, right? So it will be around 233. So HF3 will be around 233.5. 233. Take it as 233. Okay. So you have to find it accurately. So for the time being, I am just approximated. Okay. So you substitute these values here. H1 is how much? 350.5. H3 is HF3 equal to H4 is equal to 233. So you will get 200 equal to 2100 equal to m dot r into, so this is kilojoule per kilogram, okay, kilojoule per kilogram. This is kilojoule per minute, okay. So it will be 350.5 minus 233, and you will get m dot r equal to 2100 kilojoule per minute by 350 minus 233, and it will kilojoule per kilogram, and answer you will get in kilogram per minute. So mass flow rate, what will be the answer? Just calculate it. So you will get a value around 18, approximate 18, okay. So 18 kilogram per minute. So that is the mass flow rate, okay. Now what else should be found out? So first mass flow rate is found out, then power required. So power actually is nothing but H2 minus H1 only. Okay. So that is a compressor. The power, the work done in compressor, it is equal to H2 minus H1. But total power will be obtained if you multiply it with the mass flow rate. So okay, power here, power equal to m dot r into H2 minus H1. But students, m dot r is known, H2 is unknown, H1 is 350.5, right? So H2 is unknown, but you can write H2 as, so you just look at this figure. H2 will be H2 dash plus this heat, okay. So H2 can be written as H2 dash plus Cp into T2 minus T2 dash. So this is equation to find the superheat. So this is a superheat, and this H2 dash can be found out. So what is H2 dash? H2 dash is the heat corresponding to 30 condenser temperature. The enthalpy of saturated vapor at 35 degrees Celsius. So that will be around 360. So you take it as 367. Okay. So H2 dash is equal to 367 kilojoule per kilogram. And T2 is unknown. So how to find T2? That is very important. So in order to find T2, you have to use the equation S2 equal to S2 dash plus Cp log T2 by T2 dash. So outside the vapor dome, this is the equation for what entropy. Inside the equation you can find the entropy using the dryness fraction. So outside the dome you cannot use that equation. Here you use the equation of this. So what is S2? S2 is known, S2 dash also known, T2 dash is also known, T2 is unknown, CP can be unknown. So what is S2? So since this is isentropic process, S1 is equal to S2. Okay. Okay. So students, S2 is nothing but S1 itself. So what is S1? S1 is the entropy corresponding to minus 5 degrees Celsius at saturated vapor condition. So that can be found out from here. So minus 5 degrees Celsius, Sg will be around 1.56, exact half 1.560 1.5613. Okay, 1.5613. So this will be the S1, and S2 dash will be around corresponding to 35 degrees Celsius. So 35 degrees Celsius. So in between this, so it will be around 1.5 1.54879. So you take it as 1.5479. 1.5479. So this will be the kilojoule per kilogram Kelvin. Okay. So this, and Cp also you also require Cp. Cp will be at 35 degrees Celsius. Cp you will get from here at 35. It will be around 0.732 0.732 kilojoule per kilogram Kelvin. Kilojoule per kilogram Kelvin. So substitute these values in this equation. Substitute these values. So you will get the 1.5613 equal to 1.5479 plus 0.732 log T2 by T2 dash is 308. So solve this, you will get T2 equal to, so you will get it as 313 Kelvin. Okay, 313 Kelvin. So you have found out the T2, then substitute these values in here, the equation for H2. So H2 dash plus Cp T2 minus T2 dash. So students, H2 will be equal to H2 dash. What is H2 dash? H2 dash value, I think you have already. H2 dash will be around some 367. So take it as 367. H2 dash equal to 367. Okay. So 367 plus 0.732 into 313 minus 308. So you will get the value as, we will get a value around 370 or 371 kilojoule. It may not be the exact value because I'm just I was approximating certain values and all. So while you are doing problem, you have to take the accurate values itself. So 371 kilojoule per kilogram. Now you have to find the power. So power equal to 18 into 370. Take it as 371, right? 371 minus H1 is 350.5, right? So this will be around 369 kilojoule per minute, but we want it in watts, so you divide by 60, 369 by 60 kilowatts. So it will be around dividing by 60, you will get 6.15 kilowatts. Okay, 6.15 kilowatts. Students, COP is nothing but Q by power, right? Q is 210. Q means reflecting effect by compressor power or work. So this is 2100 kilojoule per minute by power in power was 6. How much was the power? How much was the power? It was 6.15 kilowatt, but in kilojoule per minute it is 369. So you substitute 369 kilojoule per minute, and so what will be the value? So you will get a value around 5.69. 5.69 COP will be 5.69. Okay. And what should be found next? So now we have to find the cylinder dimensions assuming L by D equal to 1.2 for a single cylinder, single acting compressor if it runs at 300 rpm with the volumetric efficiency of 90 degrees Celsius. So we have to find the compressor, the compressor cylinder, the diameter of the cylinder of compressor. So d equal to unknown, L is 1.2d given, n equal to 300 rpm given, efficiency of volumetric efficiency is 90%, means 0.9. Okay. So we know that theoretical suction volume or piston displacement per minute. Piston displacement per minute will be equal to what will be the how can you find the piston displacement? It is nothing but volume per minute. So volume can be found out using volume will be is equal to specific, if you have the specific volume. So what is specific volumes? You know, specific volume of reference small v are equal to capital V by m dot, right? So per minute means m dot. So capital V will be equal to m dot into small v, right? So m dot r into small v r. So since an efficiency is given, you have to divide it with the efficiency. So students, m dot r is known, efficiency is also known, but you don't know the specific volume. So how to find the specific volume? Specific volume will be obtained from gas referent table. So this is at inlet of the compressor, it is -5 degrees Celsius. So here it is there. So it will be around 0.065, almost 0.065. So volume per minute, piston displacement per minute will be 18 kilogram per minute into 0.065 meter cube per kilogram. into 1 by efficiency. 1 by efficiency is how much? 0.9. So you will get kilogram and kilogram cancel. 18 into 0.061 by zero point 0.9 will be around 1.32 meter cube per minute. So this is the piston displacement per minute. And now we have to find the dia and length, right? So dia and length. How to find dia and length? So suction volume per minute will be actually equal to piston area or cross sectional area into stroke or length into rpm. So area is equal to pi by 4 d square into L into rpm is how much? rpm is given as 300. So L is given as pi by 4 d square. L is equal to 1.2 d into 300. So V is 1.32. So substituting, so solving this equation, you will get D will be obtained as some 0.167 meter. Okay. So actually this will be a cubic equation. So d square into d will be d cube. So you have to find the cube root and all. Okay. So you will get the value of d. So L will be 1.2 d and it will be around it will be some 0.200 meter. Okay. So problem solved. Now we will move to another section